Formation of images by convex lens and its characteristics. Okay, in this totally we have 6 images found by convex lens. Okay, with different positions of the object. Let us going to discuss about the formation of images by convex lens. Okay, right now, first one. Object is placed at infinity. First ray diagram. Object is placed at infinity. Okay, and here we are going to take a convex lens. Convex lens you can represent with arrowhead outside. That I am going to consider. This is the representation of convex lens, and it is having principal axis, a line or a imaginary line which is passing through optic center and center of curvatures. This is the point we are calling it as optic center, focus F2 and center of curvature to F2. Focus F1, center of curvature to F1. Okay, double dot of focus is called center of curvature. So we can represent that as 2f1. Here this is 2f2. Okay, right now the distance must be equal. We need to consider all the distances: 2f2 to f2, f2 to o, o to f1, f1 to f1. Distance must be equal. Okay, and right now object is at infinity is representing as parallel lines which are parallel to principal axis. 2 parallel lines I am considering. One is above the principal axis, second one is below the principal axis. Okay, after incidenting on the convex lens, what happened to the light ray? After incidenting on the lens, it gets refracted according to first rule. The refracted light ray which is passing through focus. Okay, similarly lower light which is passing through optics, which is passing through focus, like this. Okay, where they are intersecting? They are intersecting at one common point. Okay, where the refracted light rays are converges, there we will get the image. Okay, where is the image formed? Here will be the image. Where is the object? Object is at infinity. Okay, what are the characteristics we have for this? Object is at infinity. Where is the image formed? Image is at focus. F1 you can represent. What is the size? The size of this image is very small. It is point size, highly diminished or point size. Highly diminished, or you can take it as point size. What is the nature of the image? Is it real or virtual? Okay, directly the light rays which are converging at common point. So we are taking it as a real image. Why? Because we can catch over the screen. So this is a real image, but we know real image is always inverted. Here top light ray which is coming down, bottom light ray which is going up. So the image will be inverted. Okay, this is first ray diagram. Okay, and coming to second ray diagram. Right now, We are going to take object. That object we are considering it before center of curvature. I am bringing the object which I am going to place before center of curvature. What the changes happens, where we get the image, what is the size, what is the nature, let us discuss. The representation must be remain same for all. This is the optic center, focus, center of curvature. Left side also will get the same, F2 to F2. Okay, right now then I am going to place an object before center of curvature. This is the arrow, I am considering it as candle. Okay, and from the candle tip I am going to consider two light rays. Okay, one is moving parallel to the principal axis and incidenting on the lens. Then what happened to the light ray? It get refracted. Refracted light ray always passes through focus. And one more light ray I am going to consider, which is passing through optic center or which is passing through focus. You can take any. If a light ray which is passing through optic center, there is no deviation taking place, it get refracted, moving like a straight line. So where it is converging? It is converging at this point. This is the image position. Okay, where is the object? Object is placed before center of curvature. Object is placed before center of curvature. Where we are getting image? Image we are getting in between focus and center of curvature. What is the size? Size of the object is more, size of the image is less. Okay, and what is the nature which is giving you on the screen? So we can take that as a real image. Real image always inverted image. We are getting below the principal axis, object is above the principal axis. Okay, so where is the object? Object is before center of curvature. Okay, image is formed between focus and center of curvature. Between F1 and 2F1. What is the size? Size of the image is less. So we are taking it as diminished. A diminished image is formed in this case. What is the nature? Already we got real and inverted. Okay, these are the two ray diagrams, and coming to third ray diagram. Okay, object is placed at center of curvature. Okay, right now we are taking a lens. We are taking a principal axis which is passing through optic center, focus, center of curvature, okay, object is placed at center of curvature. This is the object position. From this object we are going to take two light rays again. One is moving parallel to the principal axis, it get refracted. Refracted light ray always passes through focus. This is the refracted ray. Okay, and second ray which is passing through optic center. Then what happened to the light ray? It get refracted. Refracted light ray without any deviation, it passes like a straight line where we are getting image. This is the intersecting position. Okay. Where is the object? Object is at center of curvature. Where is the image? Image is also at center of curvature. Object is at center of curvature. Image is also at center of curvature. Okay. This is which is giving you real image. Real image always inverted image. Okay. Where is the object? Object is at center of curvature. Where is the image formed? Image is forming at center of curvature only. You can take this as 2f2 and this is 2f1. Okay. What is the size of the image? Object size and image size both remain same size. What is the nature of the image? Is giving you real always inverted. Okay, these are the characteristics of image when the object is placed at center of curvature. Okay, coming to fourth ray diagram. Object is placed between center of curvature and focus. 2f2 and f2. Okay. Again we are considering a lens. Principal axis, focus point, center of curvature point, optic center, focus again, 2f2. Right now placed between 2f2 and f2. Okay. This is the object position between 2f2 and f2. From this, according to rules, we are taking one light ray which is moving parallel to principal axis and get refracted. Refracted light ray always passes through focus. This is the refracted light ray which is always passes through focus. Okay. One more light ray, if it is passing through optic center, it won't be deviated. It will move like straight line. Okay. Here this is the straight line I am going to represent. We are getting the image at this point beyond center of curvature. Okay. This is the light ray. These are the two light rays which are refracting beyond the center of curvature. Where is the object? Placed between center of curvature and focus. Where is the image? Image we are getting beyond the center of curvature. Okay. What are the characteristics we have? Object is placed between 2F2 and F2. Image is, we are getting beyond center of curvature, beyond 2F1, nothing but center of curvature. What is the size? Size of the object and size of the image, which is giving you larger in size. Larger in size is nothing but magnified. What is the nature? Nature of this is giving you, we can capture over the screen. So real image is always captured on the screen and always inverted. Okay, these are the two, third and fourth ray diagrams. Okay, still two more ray diagrams are there, and one more is placed at the focus, and next one is placed between focus and optic center. Okay, coming to next ray diagram, object is placed at focus. Okay, right now I am going to take a lens. Having optic center, focus, center of curvature is called principal axis. Representation is same for all, and you need to take care of that distance must be equal so that you will get diagrams perfectly. Okay, right now object is placed at focus. Right now this is the focus. You can place an object, nothing but object is nothing but source of light. Source of light, we are considering it as here candle. Okay, from candle flame I am taking two light rays. One is moving parallel to principal axis, which is incidenting like this and get refracted. Refracted light ray always passes through focus. This is the refracted ray. Okay, one more light ray which is passing through optic center. Okay, what happens with the light ray we need to observe. This is the light ray which is passing through optic center, incidenting on the lens. Then what happens? It get refracted. Refracted light ray which is moving like this. It will go like straight line. Okay, there is no deviation taking place when light ray passing through optic center. Okay, and right now if you observe carefully, these two light rays which are moving parallel to each other, they never intersect at any point. If there is no intersection, we won't get image. But actually, if you observe carefully, the image appears to be at infinity. Okay, because if you observe rails, they are look at forward, longer distance, they are appearing like closing each other. Nothing but where we will get the image. Image is at infinity. Like that we need to consider. Where is the object? Object is at focus. Object is at focus F2. Where is the image found? Image is at infinity. Why the image is at infinity? If they'll ask you a question like this, the light rays, refracted light rays are moving parallel to each other, so that we will get image at infinity. What is the size of the image? If it is forming, then which is giving you highly magnified. What is the nature of the image? Nature of the image is giving you real and inverted. Okay, this is the information about object is placed at focus. Okay, last and final, and which is important, very important. If the object is placed at between focus and optic center. Object is placed between focus and optic center. Object is placed between focus and optic center. Okay. Right now we are taking diagram. Representation. F2, F2, optic center, F1 to F1. Right now, the object is placed between focus and optic center. One light ray I am taking, which is incidentting parallel to principal axis, and it get refracted. Refracted light ray passing through optic center. Without any deviation, it passes through optic center. Passes through focus. The light ray moving parallel to the principal axis and get refracted. Refracted light ray always passes through focus. Okay. One more light ray I am considering. This light ray which is passing through optic center. Without any deviation, it passes straight. So this is the light ray which is moving like straight line. But if you observe carefully, these two light rays, refracted light rays, are diverging away, moving away. Okay, where they will meet? These two never meet at any point. So that what I am going to do is, I am going to extend backward from where they start. Okay, so I am extending these backward like this. Here this is also I am extending back so that we can find from which the position the light rays are coming from. Okay, this is the position of the image. Where is the object? Object is placed between focus and optic center. Where is the image? We are getting image same side of the object. No need of considering this position. Just if you take the distances differently, you can find the image position at different positions. But you need to identify one point. What is that? Image is forming same side of the lens. That we need to understand. Okay. And where is the object? Object is placed between focus and optic center. Optic center is O. Where is the image formed? Same side. Same side of object or lens. What is the size which is giving you? More than the size of the object. So magnified. And what is the nature? Actually these two light rays are not directly converging. So and one more which is forming behind the lens, nothing but inside the lens. We can't catch over the screen. So such type of image is called a virtual image. Virtual image, always erect image. Erect image in the sense upright image. Okay, this is giving you when the object is placed between focus and optic center. Okay, these are the ray diagrams which is giving you by using 3 rules. Okay, this is nothing but the formation of ray diagrams by using కాన్వెక్స్ లెన్స్. ఓకే, ఈ వీడియో కనుక మీకు నచ్చినట్టయితే లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ.